Hi guys, my name is Vlada, and in this video we will integrate over the curve L scalar field x plus 3 times y times ds, where L is triangle determined by points 0, 0, 1, 0 and 1, 1. Okay. First, let's draw what we have here. This will be our y-axis and this will be our x. So we have point A. I will use green color, 0, 0, and point B is 1, 0, and point C is somewhere here, 1, 1. That's just my dog. Okay, and this is our curve. Okay, nice. So how to do integration over this curve? We are going to divide this curve into 3 straight lines. Okay, that's regular. That's just okay, you can do that. You can divide your curve in many parts as you want. So we will divide this curve in this part, plus this part, plus this part, and all these 3 parts will be straight lines. So let's do that. L will be equal to straight line AB plus BC plus CA or AC. Okay, it doesn't matter from which point we start and where we end. You saw that in the last video. So I can write to A, from A to C actually. That is just the same as from C to A. So we will divide this integral into 3 integrals and we will calculate every of them. X plus 3y times dc over the straight line AB plus integral over straight line BC of scalar field x plus 3 times y times dc plus integral over the curve AC. For example, you can write CA if you want. It's just the same. You can write here CB or here BA if you want. You will get the same result. That's nice. So this will be our curve integral over the curve L of x plus 3 y times dc. We just divided our curve into 3 straight lines and we will integrate over this line AB, this line BC, and this line AC. Let's do this integral. First integral. Okay, I will just say here A. A will be to calculate integral over the curve AB of x plus 3y times ds, where AB is straight line from A to B, A0, 0 to B 1, 0. Yeah. I remind you again that you can choose from which point to which point you can do integration. I think that this is easier to parameterize, so I choose from the point A to the point B. So first step in this integral will be to parameterize this straight line from 0, 0 to 1, 0. That will be our first step. So A will have coordinates x1, y1, and B will have coordinates x2, y2. From this we get that x1 is equal to 0 and y1 is equal to 0, and from this we get that x2 is equal to 1 and y2 is equal to 1. 0, sorry. Yeah. So we will write the equation of straight line x minus x1 over x2 minus x1 is equal to y minus y1 over y2 minus y1 is equal to t, where t goes from 0 to 1. Yeah. Okay, this is the range of t. And now let's change these values here. X minus 0 over x2 is equal to 1 minus 0, that is equal to y minus 0 over 0 minus 0. Okay. This is a little strange, but it's not very strange. I will show you how to manage this. From the first equation we have that x over 1 is equal to t, so x is equal to t. That's nice. And from this second we have that y over 0 is equal to t, which means actually that y is equal to 0 times t, and which means that y is equal to 0. It doesn't depend on t. Okay, cool. This was the parameterization of this straight line from A to B, and I will frame that with some green color. Okay, now let's do the second step. Second step will be to calculate ds, and ds is given by formula square root derivative of x squared plus derivative of y squared times dt. So x is equal to t, so derivative of x is equal to 1, and y doesn't depend on t, so its derivative is 0. Okay, this is our help calculations. So we have that this line element is equal to square root of 1 plus 0 1 times dt, which is equal to dt. So this was our second step. ds is equal to dt. Now let's plug in all this in the third step. Third step says the next: integral over the straight line AB of x plus 3y times dc is equal to integral from, let's see the range of t, from 0 to 1. From 0 to 1, x is equal to t and y is equal to 0. And we multiply that with ds, which is equal to dt. dt. Okay. ds is equal to dt. We see that x is equal to t and y is equal to 0. And range of t is from 0 to 1. So we have integral from 0 to 1 t dt, which is equal to t squared over 2, and that is equal to 1/2. This was our first integral, and it is equal to 1/2, so I will get back here this integral is equal to 1/2. Okay, and in the next video I will calculate these two integrals, and our solution will be sum of these three integrals. Okay, see ya in next video. Bye bye.